Hey there, this is Kevin Olson from kevinsguides.com, and today we are going to be looking at a project where we make a basic Pong application in Java. So I'm going to walk you through all of this. So we're going to be creating this thing that I have in the screenshot here. So the goal is just to have these two paddles. We're going to have our paddle and the PC's paddle with the ball that moves back and forth in the middle. And I'm assuming you've played Pong in some fashion before, but basically the ball just moves back and forth between the paddles, and we don't want it to cross over onto or get past like our goal or the opponent's goal. And when we do get the ball past, we get a point. If they get it past us, they get a point, and then we just reset. We're going to use very basic AI logic here, so it's not going to be anything too complicated, and I might make more advanced videos in the future showing you how to do some cooler stuff with this. But anyways, the basic specs of this or requirements are it's going to have some basic object-oriented design. The paddle's going to move by following the user's mouse. It's going to use a timer to update each frame. I'm thinking it'd probably just be like 15 or 20 frames per second. It'll have very basic AI opponent logic, as I just mentioned, and finally it will keep track of the score again. Alright guys, so let us get started. I did want to quickly mention that this entire guide is available for free in written form on my website at kevinsguides.com. I'll put a link in the description, but if you prefer to read rather than watch a video, or you want to check the source code, you can do so there. Now let's take a look at what I've created to start here. So all I have right now is the project with a source folder and a main class. I'm gonna open that with Visual Studio Code, and here we go. So my main boilerplate, I've got my class, my main method, and hello world, and I always like to start off simply with that just to make sure that the program is compiling right. Now the first thing I want to get working is the overall window or the frame, the basic GUI for the application. Because we can't play Pong without some type of window to put everything in. Under my main method, I'm just going to declare a static JFrame, or not under my main method, but under my main class as a variable up here, we have a static JFrame F equals new JFrame, and I'm going to give this the window title of Pong. And I need to make sure I import that from Swing, so that is ready to go there. And then under the main method, we can go ahead and just set some basic stuff here. So we'll do like basic, the set default close operation. That's just going to be window constants dot. We'll do exit on close. So the window automatically closes, or the program closes when we shut the window. I'm going to be using a window size here. My target resolution for the game is going to be like 640 by 480. And I want to make sure that this is just slightly larger than that because the area at the top and bottom of the screen or the window, like the title of the window, that's going to take up some space. So I want something that's just a little bigger than that. And then let's go ahead and show that window. And we can just do f dot set visible is true. Okay, that's all we should need to make a basic window. Let's run that and see if it works. And yes, it does. So we are good to go there. That close operation worked too. We are all set. All right. Now I want to create a new class in the same folder as main, and I'm going to call this Pong game. And this is going to handle a lot of our like initial game logic and a few other important things. So this is going to be like the frame or the actual panel that we put in this frame that we created in the main method. So it's going to be public class Pong game extends jPanel. And since I didn't save it yet, I didn't have syntax highlighting for a second. I forgot to make that a Java file. So ponggame.java, so public class ponggame extends jPanel. We make sure we import jPanel. And then at the top of the class, let's do some final variables here. So it's just going to be window width equals 640 and window height equals 480. And then if I want to edit these values later, I can do so. Equals, actually no, those are instance variables, so we want to put those in there. Okay, so that was the problem with that. Now, the jPanel allows us to access a very useful method since this extends jPanel. We have public void paint component, and the paint component method gives us our graphics object, which normally people just call G. So we have graphics G, and we also want to make sure we are importing that. Let's see. Let's replace that swing with a just asterisk. To get graphics working, we need to make sure we are also using the AWT package. So there we go. Now we have paint component graphics G. And what we want to do here is let's start by just like making the background color for the entire game. So hopefully you've used graphics before. If you haven't, we can just use this object to kind of paint or draw like shapes and things on our window. So super useful since we're making a game here. So I'm gonna say g.setColor and we'll use the color of black for the background. So all that's doing is setting our paintbrush color into black. You could think of it like that. And we're gonna use graphics to fill a rectangle, which is the fill rect command. And we're going to start at the top left, so that's position 0, 0, and then we're going to go over with our constants here, window width, and we're going to be going down window height. So it's important to remember whenever we're working with coordinates here that they start at the upper left of the screen. So the upper left is position 0, 0, and I think I have actually a screenshot of this if you're not familiar. Okay, so here's the screenshot. So in the upper left hand corner of the screen, we have X position 0, Y position 0, and the coordinate plane goes from 0 to infinity off to the right, or however wide our screen is. And in this case, it's going to be 640, but unlike a traditional coordinate plane, we are working kind of in the fourth quartile or quadrant of the grid, but it goes from 0 to positive y, so we're not working with negative y values here. So the basis or the main axis here, it starts at this upper left corner and kind of goes down and over instead of up and over like we might be used to in a normal math class. Now that we have that color set and we set it to fill, we need to go back to the main class and we need to add this Pong game into our main frame that we had over there. So before we set this to be visible, let's go ahead and create the Pong game. So we have Pong game equals new Pong game, and then we need to use that. So we'll just do frame.add, and we'll add the game to that frame. So we're adding the jPanel to the JFrame. If we run this here, we'll see that now instead of having the gray background like before, the background is black. The next easiest thing we can add to this Pong game would be the ball class. So go ahead and make a new ball.java because the ball is just a circle and we can put that on the screen pretty easily. So when we think of a ball, well, what types of properties or instance variables does a ball need? Needs a few things here, so we're going to do private because these are, again, instance variables. Private integers x, y, that is the current position of the ball, cx and cy, so the change in x and the change in y, the speed, and the size of the ball. And we'll also do a color where we assign the ball a color. Get our imports ready to go here at the top. So we'll do import java.awt.star. And now we can make our constructor. So we will do public ball, and we'll take all those instance variables. So I have int x, int y, int cx, int cy, int speed, color, and the size int. Then of course we can use the this keyword, and we can just set all of those different variables to what they're supposed to be. So for this respective ball, we're taking those arguments from the constructor, and we are assigning those appropriately. Speed, color, and size. Okay, so now we have all the variables in place that we need to make a ball. We also need to add a new method here so the ball can be created or like painted on the screen. So do public void paint, and we will take graphics G as our argument there, or parameter, and we'll just do g.setColor like we did before when we were making the background. Say g.setColor. So whatever color the ball is the color we are using here. So this color, and then we'll do g.fillOval, the x position, the y position, and then we're going to go over the width of size and down a width of size. That is pretty straightforward. Let's return to the Pong game class and test that out. And we need to create a ball object within our game. Start by creating a constructor for a Pong game. So we're just going to have our standard constructor here. So public Pong game. We won't take any arguments. And we need to make an instance variable before with the constructor. So we have private ball, game ball. So we declare the ball up there. And we initialize that within the constructor. So the game ball is going to be a new ball, and we start assigning those values. The first one's going to be the position of the ball, and remember, since the screen is 640 by 480, we want something that's kind of like in the middle here. For the change in x and the change in y, I'm going to go with a value of 3. That means that the ball is going to be going over 3 and down 3 every frame. That speed should match the CX and CY, so that is also 3. The color is just going to be color yellow, and the size of that guy is going to be, let's go with 5 and see how that looks. Okay, save that. Now we've created a game ball, but we still have to paint it on there as well. We have access to the game ball variable since it is declared at the class level. We can go down to paint component, and we can just call game balls paint method that we created earlier, and we just pass along that graphics object G. Save that, and if I run the program now, let's see here, I run the program, and we can see we have a yellow ball at the center of the screen. And that ball is a little small. I think I do want to make it larger. Let's go with a ball size of 10 instead. That looks a little better. Now the next logical place to go from here would be to create the game timer, and that timer is going to run once every, well, many times every second. I'm gonna maybe go for about 30 frames a second. And each time that timer goes off, we are going to call the Pong game's paint component method, and that's going to repaint the entire screen. So that's going to be like a frame. And we are also going to have some logic that handles the movement of the ball and later the paddles and everything else. Okay, I've decided I want to put the main timer for the game in my main class under the main method. Let's go ahead and take a look at the main method here. So to create this timer, what we need to do is first, of course, we need to declare it. So do timer, and let's make sure we are importing timer, and we want to use these. There's a few different timers that are included with the Java API. We want to use a swing timer here. So import Java X swing timer. And timer equals new timer, and we're going to give it a delay of 33 milliseconds. So that's in milliseconds. If we open up a calculator here, there's 1,000 milliseconds in a second, and if I'm shooting for 30 frames per second, then I need my delay to be once every 33 milliseconds. And the second argument we're passing along here is a new action listener. And then that all goes in there, so we have that kind of method in here, and we need our semicolon at the end. And the action listener has a useful override for where we actually do the event. So the timer has an action listener with an action event, public void action performed, action event, and E for our event. And now whatever code we want to repeat can go in this internal method here. And let's make sure we are importing everything we need. So I'm just going to do import action event, and that imported action listener too, so we're good to go there. And whenever that timer goes off, all we're going to want to do is repaint the screen for right now. So we call our game's repaint method. And under repaint, and that is because we extended the JPanel, so that automatically calls paint component for us. So we don't have to write a separate repaint method. We can just magically kind of use that. Now, if I run the program, it shouldn't really look any different, but the important thing here is that there are no errors. So I can probably assume that the timer is going and it's repainting properly. And if I really wanted to check here, I could do like system out.println test in my timer action performed block there. And I can see that I did forget to do something here. And this is something I always forget to do when I make timers, is to start them. So they do not automatically start. So we just need to make sure we do timer.start after we create our timer in the main method there. If I run the program, now I can see in my command window it's just spewing out the word test again and again and again, so I know it is working. Now let's remove that test line and start working on the ball's movement. So where we put the ball movement is kind of up to us, but I think I'm going to put this logic in the ball class. And I'm doing that so for a number of reasons, but I want this because like the ball's movement is kind of something that only the ball is going to be doing. Um, I don't want it to be handled in like the Pong game class or the main class. I want this all to be handled with the ball class itself. So we'll do public void move ball, and that's going to be a void method, so it doesn't return anything. And all we're doing here is changing our value of x and y. So we're going to say increment x by cx and increment y by cy. So take x, add the change in x to it, take y, add the change in y to it. So every time that the frame is regenerated, I want to call this move ball method. Now, where do I want to call this from? The class where I made the ball was the Pong game class, so I should probably create a new method in here to handle all the game's logic. And this is where I'm going to go ahead and actually move that ball. So game ball dot move ball. So every time the timer goes off, I'm going to be calling not only that paint component method, but I'm also going to be calling the game logic method. So under our timer with game dot or with our action performed action event E and our timers event here, we're going to do game logic. So not only do we repaint the screen, but we also do all the logic over again. Now if I run this program, we can see the ball just kind of spews off to the bottom right because remember when I first created that ball in Pong game, I gave it a CX and a CY, both of +3. So it's going over 3 and down 3, over 3 and down 3, over 3 and down 3 every single time that the timer in the main method goes off now. Okay, we're in the ball class again, and the next piece of logic I want to handle is making it so that the ball can bounce off the left and right side of the screen, and the top and bottom. So we'll do public void uh, bounce, actually lowercase bounce off edges. And we're going to take two arguments here. We're going to take an integer top and an integer bottom. And the reason I'm not doing left and right, at least within here itself, is because remember for Pong, when the ball goes over the left or the right edge of the screen, it's actually out of bounds, and that counts as a point against the user or the PC. So we really don't have to do that logic, but just for demonstration, I will include that for our testing. So if y is greater than the bottom of the screen, the ball's y location goes below the bottom, we are just going to reverse the y. And I could do this a number of ways, but because I'm trying to make this as generic as possible, I want to include that as a separate method. Now, I'm going to implement that in a minute, so we don't have to worry about that for right now. Then if y is less than the top of the screen, so if it goes over the top of the screen, we are going to reverse that y again, right? Now let's implement that reverse y method. And let's see, does this, yes. Okay, so I can just use a short code there to insert a public private void reverse y. And all this is going to do is set the change in y to equal itself multiplied by -1. And we might as well do one with reverse x as well. And that's going to do cx times equal -1. So let's just test it with the top and bottom here. So if I do that, we should see now when it goes to the bottom, and looks like it kept going there, and that's because I did not include this logic for the bounce off edges anywhere in the game logic. So that needs to be involved here too. So when the game ball gets to the edge, we need to make it so it bounces off the edge. And I'm not sure why it says that, but the top of our screen is at the position of 0, and the bottom of the screen is at the y position of our window constant, so I just had a window height. And now when I run the program, hopefully it bounces this time. Yes, it did bounce. It went over a bit farther than perhaps I would have liked, but it did bounce. So we are good for that. And again, it doesn't need to bounce off the left and right side of the screen, but for the sake of our demonstration here, let's go ahead and make it so it does that. So if x is less than 0, so if it goes over the left edge, we'll have it reverse x, and if x is greater than the window width of 640, we will reverse that x again. And if I remember, we're going to actually come and remove this unnecessary code later. But for now, we should have a ball that starts in the center, and it bounces off all the different corners of the screen, or edges of the screen. And if you're paying attention here, you'll note that when it bounces off the top and the left side of the screen, it doesn't disappear over the edge like it does with the bottom and the right side of the screen. And that is because when it is bouncing, it is actually bouncing based off of, or the ball's position is based off of the top left corner, just like the screen and everything else position is. So when the ball is at position, say 10-10, really that 10-10 is just the top left corner of the ball. This kind of area off to the top left there. It's not the center of the ball or anything like that. So if I want to make it look more like it's bouncing off the center of the ball, or if it's actually bouncing off the edges, all I have to do is offset this for the bottom of the screen and the right side of the screen. I want to offset that by subtracting the width of the ball itself, and that was the size variable, so minus this size, and if it goes over the bottom, minus size. Now if I run this, the bouncing should look a bit better. And it's just going over a bit here because I don't have the window size properly. But if we take a look at the overall size of the black box, remember, is 480 by 640 exactly. So now we can see it pretty much goes right to the edge of that black box and bounces where it's supposed to. The next important thing I want to get working is the game's paddles. Let's go ahead and create a new paddle class. So make a new file called paddle.java, and we automatically got the class declared there to begin. And a paddle is another object just like a ball, so we need to give it some instance variables. So what properties does a paddle need to have? Well, it needs to have a height, an X and a Y position, just like the ball does. And we're going to have our paddle have a certain speed, so it can only move up and down a certain amount each frame. And this will add kind of a level of difficulty to the game by not letting the user just instantly teleport the paddle from like the bottom of the screen to the left to the top of the screen. That would make it a little too easy. So we'll have it move at a limited speed. And we'll also give a paddle a color as well. So we have height, X, Y, speed, and color. And then we'll also do a constant static final integer paddle width, and this constant's going to be the width of the paddle in pixels. I'm going with the number 15. Now I need to make sure I am importing everything I need for that color to work. So let's do import java.awt, and we'll just use a star. That should make that go away. Perfect. Now do a constructor for a paddle. It's going to be a standard constructor, public paddle, int x, int y, int height, int speed, and color. So we get all of our arguments for the constructor. We assign the values just like we would with anything else. This x, this y, this height, this speed, and this color is color. We take all these, we pass them in, and we set our instance variables when a new paddle is created. The next thing we want to do is a paint method, just like we had in the ball class where the paint method handled the drawing of the ball. We want the paint method in the paddle class to handle the drawing of a paddle. So we're going to set g.setColor, color, so whatever color our paddle is. And one of them is going to be red, one of them is going to be blue. And instead of fill oval, we're going to use fill rectangle, so fill rect. And again, we have our x position, our y position, the width of the paddle, which is that constant paddle width, and the height of the paddle. The reason I did not use a constant for the height, you could do that if you wanted, but I wanted to make this so it could be changed down the road if, say, we want to add additional features to the game where like the paddles get taller or shorter. We might want to be able to modify that height value. But if you plan on always having the paddles the same height, then by all means go ahead and make the paddle height a constant. Anyways, back to Pong game where we create our objects. So in the regular constructor, we're going to need two paddles. We're going to need the user's paddle, and that's going to be a new paddle. We want it to be on the left side of the screen. So I'm going to have the player or the user, they're going to be on the left side, and then the PC is going to be over on the right side. So the user's paddle is a new paddle. It's going to start at a position of, say, 10 to 100. So we're going over 10 and down about halfway, a little less than halfway. And we want this to have a height of 75 to start. I'm going to make the speed no, let's make it a little faster. Let's go with 3 and see how that works out. We can always change it later if we need to. And the color here is going to be color blue. Okay, and I need to make sure too that, like I keep forgetting to declare my variables. So we need private paddle, user paddle, and PC paddle. So I declare those guys up there. And PC paddle is going to be a new paddle. This time, instead of starting at an X position of 10, I wanted to start closer to the right side of the screen. So remember, in this case, my screen is about 640 wide. So I want to do something a bit less than that. I want to make it so it's over far enough where we have some space between the paddle and the edge, but we can still see it. So it needs to be less than that 640. And I'll start that at the same height or the same X location, or no, the same Y location that I had the user's paddle set to. And the height's going to be the same, the speed's going to be the same, and the color is going to be color red. Alright, so we've declared the paddles. And we have the paint method ready to go. The next step would be in the paint component method. We need to make sure we are painting those panels. Paint the paddles, so user paddle dot paint G and PC paddle dot paint G. Perfect. If I run here, we can see it's starting to look more like a Pong game. We have our ball and we have our paddles. Okay, the next thing we want to work on is the movement of the paddle. There are a few different ways we could approach doing this. But the way I want to make this work is I want the paddles to kind of have a target Y position between 0 and 480. And then every frame, depending on the value of the target Y position, I'm going to have the paddle kind of be nudged or like move in that direction at the speed that we set. So the paddle is going to have a new method here, public void move towards, and int is going to be moved to this Y position. And I'm just writing that out so we know what it is. So I want it to move towards a certain Y position. And then if I take a look at my website, I kind of have this graphic here, but I don't want it to move to the top. I want to base this value kind of on the center of the paddle itself. For example, if I was at the Y position of 200 on my screen, I want the paddle center to move to that Y position of 200. I don't want the top left corner of the paddle to move to that Y position of 200. So I want that paddle to be centered. And to calculate the center of a paddle, all we have to do is take the paddle's Y position, which is the top of it, add the overall height of the paddle to that, and divide that value by 2. Of course, since we do know the absolute value here of the paddle's center or the height of the paddle, it's like for our purposes right now it's a constant. We could just take 75 divided by 2 and make that y plus whatever that value is, 30 something, 37. But in this case I do not want to do that. I want to make this generic. Again, in case down the road I want to base this off of a changing height. So if I want the paddle heights to be changeable. Let's return to Visual Studio Code here and our move towards method. So we need to find that center Y location. So int center Y, and this is the center of the paddle. It's going to be equal to Y plus height divided by 2, just like I explained a moment ago. And then I need to remember, so we're getting this move to Y variable, right? So say that our paddle is near the top and we want the paddle to move towards the bottom. So the paddle's currently got a Y variable, that value is 0. The mouse is at 200. Then I want the value of Y to increase to move towards that Y value. So, and then of course we want it to do the opposite. If I have the mouse at the top and the paddle is down here somewhere, then I would want that Y value to decrease each frame until we hit our target or come somewhere near our target. So if the center of the paddle is greater than the position we're moved towards, or we're moving towards, so if the center is greater than the position we are moving towards, we need to go ahead and make the paddle start. That means that the paddle is below the mouse and we need to make the paddle move up, which means we need to decrease the Y values. So Y minus equals speed. Then we just do the exact opposite for the other direction. So if center Y is less than the move to Y, we can go ahead and do Y plus equals speed instead of minus equals speed. Now, let's actually go and test this out. So how can we test this? Well, an easy way would be in the Pong game class where we handled that game logic. We can just use some like predefined stuff here. So we have our user paddle dot move towards, and let's say I want to move that towards 0. And the PC's paddle, I want to move that towards like I don't know, let's just pick a number that's off the screen. Let's move it towards 600. Now each time the frame goes off, my paddle on the left should be moving up towards that 0, and the PC's paddle should be moving down towards 600. And we can see that that move towards method is working properly because now the center of my paddle, so you can see my paddle is kind of cut in half here. So I know that my center logic's working and that that moved. And if I go down here and make my screen a bit bigger, we can see that the PC's paddle or the AI paddle is now way down there at 600 like it's supposed to. So let's delete this for now. Let's delete that test code now that we know that that's working. And the next thing I want to do is make it so that the paddle, at least the user's paddle, can move in accordance with the location of the user's mouse. So if my mouse is at the top, I want the paddle to start moving up towards it. If it's down below, I want the paddle to start moving down in that direction. Now, the best way we can go about doing this is to look at so we're still in our Pong game class here. And in addition to extending the JPanel class, we want this method to, or this class to also implement a mouse motion listener. Now, since it implements mouse motion listener, we need to make sure that it's implementing these abstract methods. So we're gonna just use a quick fix to add those unimplemented methods. You could type them yourself if you wanted, but this will kind of get us started here. And I won't be using the mouse dragged method in this, but I don't want it to throw an exception either if someone does drag their mouse, so I'm just gonna leave that empty, which is fine. And we're taking a look at mouse moved, so this fires every single time the user's mouse moves, and it gives us this mouse event E, which we can use to find the actual location of that mouse. So before we start tracking the location, we also need to make sure we are adding the mouse motion listener, and we do that in the Pong games, public Pong game. So when we first construct a Pong game, let's say user mouse Y is going to start at 0, and that's going to be an int. So private int user mouse Y, just the variable we use to track the user's Y location. And we're going to add a mouse motion listener and this. So this object itself is the mouse motion listener, or is using the mouse motion listener. So we're listening for mouse motion events on this object, which is our JPanel or our Pong game. So the entire Pong area, the entire window is going to be listening for mouse events, basically. Now returning down to mouse moved, whenever the user moves their mouse, we can use user mouse Y. We're going to set that equal to the event dot get Y. So we get the Y value for that mouse movement. And now that we have the user's mouse Y location, we go back to the game logic method, still in the Pong game class, and let's have our move, let's see, okay, whatever, we'll leave that as is. And under game logic, what we want to do is every time, remember game logic fires every single time, just like the paint method does. So we want the user's paddle, and we want to call that move towards method that we created earlier, and we're going to have it move towards the user's Y location. At this point, we have a method to track the user's mouse. We set user mouse Y to whatever that Y location is. And then every time the frame timer goes off, or our main game timer goes off, we have the user's paddle move in that direction. Let's test that out. Perfect. So now we can see when I move up and down, the paddle kind of does attempt to follow my mouse, and it moves at that speed of 3. But you will notice that we kind of have this, hopefully the video picks it up, but and kind of get this jittery effect going on where the paddle appears to wobble up and down between 2 points, and depending on where I'm at, it won't, or it'll stop or start doing that. But this has to do with kind of like some inconsistencies in how I calculated the location of the paddle with regards to the mouse position and the speed of the paddle. So if I'm at a certain point here and that happens to land, remember that the paddle can only move, it can only move up or down 3 at a time right now. It can't move in increments of 1 or smaller. So when the paddle is kind of jittering up and down like it is here, it just is happening because that that paddle is trying to move up and down 3 every time, but the exact Y location that I'm at with my mouse is somewhere between that 3. So if the paddle's at position 100 and my mouse is at a position 101, then the paddle is going to say, oh, okay, I need to move down 3. It's going to jump up to 103. My mouse is still at position 101. It says, okay, well, 103 is greater than 101. I need to move back up to 100. And it just keeps doing that again and again and again until, and that's what creates that jittery effect. The easiest way to fix that is to just kind of add a little bit of tolerance with regards to our movement. And we will do that by modifying the move towards method of our paddle class. So when we're moving up and down by whatever the speed is, what we need to do before we actually fire these events is determine if we're already kind of like in range. So if I'm already, let's say within, I don't know, 5 pixels of where I'm supposed to be, instead of moving the paddle, let's just leave it where it is. And to do that, I'm just going to do if math that absolute value of the center y minus the position I'm trying to move to. And if that is greater than, let's do, actually, I can do 5. No, that's greater than 5. Then I will have it move. Actually, instead of 5, let's just do speed. So remember, my speed is 3. So if I'm off by more than 3, then it's going to move the paddle. And if I'm not off by more than 3, it's just going to leave it where it is. Nothing's going to happen. Let's try running that. And now, no matter where I go on the screen, the paddle kind of finds the location of my mouse and it stops. It doesn't do that jittery thing like it was before. So we are all set to go there. The next thing I'm going to do is make it so that the game or the PC paddle moves as well. And the easiest way to do that would be to, for now, since I'm just making this as simple as possible, all I'm gonna do is when the ball's moving around on the screen, I'm just gonna have the PC kind of try to match whatever the Y position of the ball is. So if the ball is at the top, I'm going to tell the paddle to move up towards that Y value of the ball. And if it's at the bottom, I'm gonna have the ball move down, or the paddle move down to match that Y value of the ball. Before I do that, I'm gonna have to put a getter method in for the ball class. So we'll just do public integer get y, and all this does is return the current y value of the ball. And again, of course, we're in the ball class here. Then if I go back to the Pong game class, so where I handle the game logic, so in addition to moving the user's paddle, I'm going to say PC paddle that move towards whatever the game ball's get y position is. So the game ball's y position. If I run the code now, both my paddle and the PC's paddle should be moving. And since it matches the Y position of the ball, you can see that the PC's paddle pretty much perfectly tracks or lines up with the actual position of that ball. Now, of course, that's not going to be very fun if the PC can't lose, but because it's always on the same point as the ball, and we're going to put some more code in later to kind of make it so that the PC can move. And I'll also explore how to add additional, like more more advanced kind of AI type features to this in the future. Anyways, the next thing we want to do is make it so that the ball, in addition to bouncing off the top and bottom of the screen, we want it to be able to bounce off the paddles. And now since I'm going to start handling the paddle bounce logic, we can get rid of that code before where I had the ball bounce off the left and right edges, so I don't need to worry about the X position of the ball as far as bouncing off of edges goes. But I do need to not worry about the paddles and gliding with paddles. There's a few different places where we could do this, but I've decided to do this collision check. We could do it in the Pong game class and create a method that checks the collision between a ball and a paddle. We could do it in the ball class and have a check collision method with the paddle here. We could do it in the paddle class and check collision with the ball. I'm going to be doing it in the paddle class, and the reason why I decided to do it that way is just because I think it makes sense because it's specific to the paddle. It's also specific to a ball, but it's an interaction between a ball and a paddle. The ball can interact with other objects, and if I wanted to like reuse a lot of this class in the future, I might want to reuse this ball method, but I might not necessarily need to reuse this paddle method. The paddle seems like a more kind of specific object to a Pong game than a ball is. A ball is just slightly more generic, so that's why I'm putting it in the paddle class. But ultimately, where you decide to put it is up to you and the needs of your program. But I'm putting it in the paddle class. My Pong game class probably would have been another good option. Um, but anyways, so we can do let's see, we're going to make a public void check collision. Actually, should this return something? Yeah, so it's not void, it's a boolean. So check collision with a given ball. All this method does then is checks if this paddle is colliding with the ball. Then of course the parameter b, so the ball is the ball and it's going to return true if colliding and false if not. Now how am I going to check for this collision? Well, remember I already have a way, what variables do I currently have access to? Currently I have access to the X and Y position on the paddle. I just got a ball. I have a way to check the Y position of the ball. I'm also going to need a way to get the X position of the ball, so I know where that is. So public int get X in the ball class, and that's just going to return X, or ETURNX. Then back in the paddle class, we need to start thinking of how we can create this logic. So what I want to do is find a way to calculate the left and right sides of the ball or of the paddle. We know that the paddle's X position is going to be the left side, right? And therefore the right side of the paddle is going to be X plus whatever the width of the paddle itself is, which in this case was 15. It might make sense just to make that, I already have that as a constant, so I can actually just use that paddle width variable. So let's say we know that our x is the left side, and we need to calculate the right side of the paddle, and that's just equal to x plus the width of the paddle. The y value of the paddle is, remember, the top of the paddle, so the bottom y of the paddle is going to be equal to the paddle's y position plus the overall height of this paddle. To check the collision with our ball, which we're calling B, we want to see if it is between the x values and the y values of the paddle. So if it's between the left x and the right x, and if it's also between the top y and the bottom y, then we can report back that a collision has in fact happened. So if b.getX is greater than the x position of this ball, so if it's greater this paddle, so if the ball's um, between the or coming into the paddle from the left side, so if it's past like the left side of the paddle, and if it's also past the or less than the right side of the paddle, then it's horizontally between the paddle. So we know it's like between the paddle going from left to right. And then we have to do the same check from top to bottom. So if b.getY is greater than y and b.getY is less than the bottom of the paddle, then at this point we know it's between the top and bottom of this paddle. And we can return true because we know it's that a collision must have happened. And I forgot to include my parentheses there. Then all we have to do here is return false, because if we got to this point without returning true, then it must not have collided. So now we have a way of detecting if a collision occurs. Now, how do we go about incorporating this into our actual game? Well, back in the Pong game class under the game logic, so we move the ball, the paddles move to wherever they're going to be. At this point, how about we check for that paddle collision? So if our user's paddle dot is check collision, so if it's colliding with the game ball, then all we want to do is reverse the x direction of that ball. We can do the same thing with the PC paddle. Dot check collision with the game ball, and then we can do game ball dot reverse x again. Let's go back to the ball. Did I not make that reverse x? So I made that private, so I just need to make that public so I can use it from the Pong game class. All right, let's test this out. Now it should detect collisions. Yep, it collided with my paddle there, or with the PC's paddle there. And if I go here, it should also detect a collision with my paddle, and it did. Then it should just keep going, and since again the PC is always set to match the Y position of the ball, and the paddle moves at the speed of 3 and the ball moves at a speed of 3, it's always going to be able to hit it. But if I miss it, we can see that the ball just keeps going off to the left like we would want. And at that point, we know that I have lost a point. Now let's take one more look at this real quick and see what happens when the ball collides I'm not sure if you could see that very well, but you might notice that the ball kind of disappeared into the paddle. And again, this kind of has to do with the X and Y position of the paddle and the ball starting from the top left of the axis, in the same way that I mentioned earlier when it was kind of bouncing off the bottom left and right side of the screen. It would kind of go all the way over that black edge on the bottom right. It's doing the same thing with paddles now, and I think I have a diagram to illustrate this too. Hopefully that makes a little more sense. But right now, this is what's happening. So the ball comes in from the left. It is colliding, but the collision is actually detected at this point here, where the ball is already inside of the paddle. And this only applies to the PC's paddle. It doesn't apply to the user's paddle because that detects it coming in from the right, and in that case, the math works out. But the solution here is pretty simple. Again, all we're going to do is offset the position of the ball where we check the collision. So we can kind of imagine that there's like an invisible paddle in front of the PC's paddle, and we are just shifting the X position where we detect the collision over by whatever the width of the paddle is. And actually, I think I did just misspeak there. I don't want to offset it by the width of the paddle. I want to offset it by the width of the ball. Just the way it's drawn here, it looks kind of like they're the same. But remember, the ball I think is a bit smaller than the width of the paddle. So the ball's width is 5. I just want to make sure that we are detecting the collision from the left, offset by 5. All we have to do is subtract 5, or the ball's width from x, and we can do that in our check collision method. So if b dot get x is greater than, instead of x, let's add a bit more logic in here. So I'm just gonna do it's greater than x minus the size of the ball. And to get the size of the ball, I'm gonna have a method in here that returns public int get size. So I need a getter for that, and that just returns the size of this ball. So if x minus b dot get size, and that should fix it from coming in from the left side. I don't really need to worry about that for the user's paddle on the left, since it's never going to come in from the left for the user's paddle. But now if we look here, it bounced off the edge of the PC's paddle instead of going through the PC paddle a little bit and then bouncing. So now that looks a bit better to me, and we are good to go there. Now, since this is annoying me, this might have to do with just my screen resolution, but if I extend this out, you can see that the window is kind of, it starts in here, but the screen actually is playable out a bit farther. I could make the game window itself smaller, or I could make the overall JFrame a bit larger, and that's what I'm gonna do here. Alright, so the way my screen's currently set up, a width of 650 and a height of 515 seems to be kind of like the magic spot. And since I'm using my computer on like a higher DPI right now for the purpose of this demonstration video, my screen resolution and stuff might be a little janky. But anyways, now that that is resolved, let's take a look at scoring. So how do we check if one of the people scores? Well, all we have to do is see if the ball's X position gets either past my paddle or past the PC's paddle. The easiest way would be to just set it to be like if it goes below 0 or above the width of the window, then we know that that either the user or the PC must have missed the hit because it didn't bounce off the paddle. And we can reset things there. So let's go back to our Pong game class, and let's create some new instance variables. I'll do private. Actually, I can just add this to our list of integers here. So private int user mouse y, and we'll also have a user score and a PC score. Whenever it gets past the opposite person's paddle, you can get 1 point. And then as far as the score itself, we need to display this on the screen somehow, and we can do that in the paint component class. I'll just make a new area down at the bottom that says update the score. We'll set the color to g.setColor, color dot white. So we set that to white, and that'll look good on our black background. And we can use the graphic.draw string method here to actually write out a string. So if I do score user, and then maybe I'll have some brackets to kind of format that. So I want to do score user plus the actual user score, right? Then we'll close that bracket there. And then we'll just put the PCs next to it and do the same thing with brackets. So I print out the PC score, we close that bracket, and then we have to give it an X and a Y position like anything else. I'm going to put this at 250-20. Let's just make sure that works. Yep, that's pretty much centered to me. So the score, the user 0, PC 0. Of course, I won't update yet because I haven't added that logic, but at least we can now see the score, which is important for a demonstration. Now, where should we do this check to see if someone loses? The easiest place to put this would be in the game logic method. Since again, this fires every single time the timer fires and the frames update, this is where it makes the most sense to see if someone wins or loses. So if the game ball dot get x, so if the x position of the ball is less than 0, that means it goes over the left. That means that the PC has scored. So we can do PC score plus plus. And otherwise, if the game ball dot get x, if it goes over the width of the entire window, then the PC has lost a point, and we can increment the user score by 1. All right, we know that the PC can't lose, but let's see what happens if I lose, just to make sure that is working. Remember, we should always be testing incrementally as we go along. So it bounces off the top and goes past my paddle. And perfect, so the PC score is incrementing. Now, of course, it's going to keep jumping up like it is right now because I haven't added any logic to reset the game after it detects that one of us misses the paddle. So PC is just infinitely scoring every single frame right now. Anyway, the next logical step would be to reset the game so we can start the next round. And we'll do this in the Pong game class as well. Maybe right after our game logic, we can create a new method just called reset. So public void reset. And to reset the game, we need to reset the position of the game ball. And actually we need to create some setters and getters here. We could do this one of two ways. We could just create a new game ball object. That would be the fastest way to do it. So if I just go back to my constructor here, I can just copy the game ball's logic for the game ball and paste that in my reset method, and that basically just creates a new ball. We assign game ball to that new ball and all the variables start over. So that, I think, is how I want to do this. And we will leave the mouse motion listener as is when we reset the position of the paddles as well. I think in my written tutorial I did it a little differently. I created setters for all the different variables, but I think this is just a faster way to do it, so we will do it like that for now. Actually, we will need to create some setters in the future still, but whatever. Let's just test this out and see how that works. So if the PC loses a point, we're going to reset the game. and if either of us lose, we reset. So let's call that reset. Now, when I run the program, if the PC hits it, and let's just move my paddle way down here so I can't not miss it. So I miss it, and we see that the ball jumped back to the middle, the paddle is reset, and the score is not going off into infinity anymore. So we have successfully created a way of adding a score to our game. So the final thing I want to do here is have some way for this game to get more difficult, because at the moment, the way it's set up, it's impossible for the PC to lose. There are plenty of different ways that we could go about doing this. One way would be to have it like a random chance that the paddle misses. So we could say that every time it bounces off of my paddle, maybe there's like a 1 in 5 chance that the PC just intentionally misses. But if we do it that way, it's gonna look pretty obvious that the PC is like intentionally missing. We will see that it's like off from the beginning. So I don't want to do it that way, but there are ways you could, of course, make that look better. For the sake of this video, all I'm going to do is after every 5 bounces or so, I'm going to have the speed of the ball actually increase by 1 unit. And doing that will make it so the PC cannot always keep up with the speed of the paddle. In that case, with the ball moving faster, we'd have to predict how fast the ball is going. We see it's moving faster, and we need to make sure that, since again, say the ball is moving at 4 units every frame, our paddles can still only move at 3 units a frame. So we need to preemptively kind of predict where the ball is going to go. And the PC won't be able to keep up with that, and it will just miss. Now that's not perfect either. It's gonna work the same pretty much every round. It's gonna be still a boring game, but at least now there is some level of difficulty, and the PC will be able to lose just like the user can. Let's keep track of the amount of times we are successfully able to get a kind of bounce going back and forth. So in our Pong game class, I'm going to add yet another private instance variable of type integer, and I'm just going to call this bounce count, and that's going to count the amount of times that a bounce has happened. When the game starts, I'm going to set bounce count to 0, and we might as well do that in the reset method as well. So when we reset the game, the bounce count is going to be set to 0. Then every time a bounce occurs, which again happens in the game logic, so when the user's paddle or the PC's paddle collides with the ball, I'm going to reverse the game ball's direction, and I'm going to increase bounce count by 1. So bounce count plus plus. Alright. And then once bounce count gets to like 4 or 5, what I want to do is increase the speed of the ball. Now, have I created a set speed for the ball method or class yet? I have not. There are 2 ways we could do this. We could use a setter and getter for speed and do it in the Pong game class, or I could just create an increase speed method in here. So public void, I think that's what I'll do in the ball class, increase speed. All this does is increase the speed of the ball by 1. And maybe we should set a max speed constant too. Static final integer ball or max speed. And let's set that to 6. So if we go above that, it's going to be impossible. Back in the increase speed method that we're working on. So if the speed of this ball is less than whatever that max speed constant is, we can go ahead and increment speed by 1, And in doing that, we also need to increase the Cx and Cy. So remember, Cx and Cy are the change in x and change in y for the ball. So it can be positive or negative, but we want the absolute value of those to be the speed of the ball. So if the Cx is currently negative, I want it to be -4. If it's positive, I want it to be +4, and so on and so forth. There's a couple ways we could do this. But one way we could do it is just to use an absolute value, and I could do the change in x is equivalent to the current change in x divided by the absolute value of that change in x multiplied by the speed. So this is just one way to do it. And what this is doing is, so let's say that Cx right now is 3, right? And we want to make it go up to 4. So it's saying Cx is 3. I take 3 divided by 3 and multiply that by 4. That gives me 1 times 4, which is 4. If it's negative, Cx is negative, then we are doing, say, -3 divided by 3. Now we have -1 instead of 1 here. -1 times our new speed of 4. Now we have a speed of -4 for our change in x. That's how that works. Another way we could do it, and let's just do it differently for change in y, just for demonstration purposes. So the other easy way, if this makes more sense to you, so if a change in y is negative, so if it's less than 0, then all we have to do is set change in y equal to -1 multiplied by the current speed. And otherwise it must be positive, in which case the change in y is just going to be equal to that positive speed, because the speed variable itself is always going to be positive, but the change in x and y, that can be negative or positive. These are two different ways of doing the same exact thing. Whatever is easier for you to understand. I think this way is a bit shorter, but if you prefer doing it this way, that's fine as well. Now that we have that increased speed method ready to go, we can add that to our game logic. So if we go back to the Pong game class under game logic, where we check the collision and we increase the bounce count. At this point, before we do anything else, let's say if the bounce count gets to, um, for the sake of testing, we can make it something maybe lower. I might want to use something like 5 in actuality, but let's just make it 3 for now. So if bounce count is equal to 3, we can just do game ball dot increase speed, and that ball will start moving faster. Let's run and test. This is our first bounce, and I have to make sure I actually hit the ball. 1 bounce, 2 bounce, and the PC should hit it a 3rd time here, and then I should notice that the ball is moving faster at that point. And you can see the ball is definitely moving noticeably faster. I missed it in that case because I am clearly not a professional Pong player, but you get the gist of it. When the ball is moving much faster like that, it should make it so that the PC can lose, in addition to, of course, it being more difficult for me to play. So the PC hits it that 3rd time there, and where am I going to move my paddle to? Like right here. Okay. And now we see that the PC missed because it wasn't able to keep up with that. So that's actually how it's going to go every single game, the way I currently have it set up. We can make it a little different by like randomizing the starting position of the ball, the starting speeds of the ball. There's a ton of different things we can do with that, but for the purposes of this video, I think I'm going to stop this here, and in a future video, we will take a look at making the computer a little smarter with regards to tracking that ball, and maybe play around with some other fun features that we can add to this game. So I hope you learned something from this. Thank you for watching, And if you appreciate my videos, feel free to leave a tip on my website, and the source code is available in the description.